the recording for 5-4 Algebra 2 notes. 5-4, here we go. Let's talk about some things here. In the past, we have had to graph, so we're doing graphing, but this is not terrible graphing. This is probably the easiest graphing we've done, okay? In the past, we've had to graph linear functions, right? Put this at the top of your paper. Linear functions are like y equals x, and what does the graph of that look like? Like a straight line, like I'm going to put like that, okay? Then we have like quadratic functions. U is y equals x squared, and that's a u. You are right, okay? Then we have like cubic functions, okay, which is y equals x to the third power, and that looks like a
S.
Kind of like an S. Yeah, that was not very good. But anyway, make yours look better. Kind of like that-ish, okay?
English kind of.
X to the fourth power, x to the fifth power. We could keep going. Let's talk about something different. Let's talk about like absolute value. Do we want to know what an absolute value looks like?
That's the one that.
He looks like a V. Yeah, a perfect V. Quit throwing that. Okay, he looks like a perfect V. And we could go on. There's a couple others that we know what the graph of them looks like. But today, we're graphing square root function. And I'll show you at the end why we're graphing square root functions. A square root function looks like y equals the square root of x, right? The square root of x. And do you know what he looks like?
No.
It's right here.
Oh.
If you use your resources.
I think it looks like.
He
like a,
starts at 0 and he does a little like zippity thing, right? He starts there and he does a little zippity thing. Okay, if I plot points for this, okay, let's say I do this and my function is the square root of x, okay? Let's say I plug 0 in. What is the square root of like 0? 0, right? Let's say I plug in 1. What's the square root of 1? 1. Okay, what's the next number that has a really nice square root? I don't want to do 2. 4. What's the square root of 4? 2. Next number that would be nice would be 9, and that's the square root of 3. So like what this saying is like 0, 0. I go over 1 up 1. I go over 4 up 2. I go over 9 up 3, etc. Right? Like that's what this thing looks like. So he's gradually going up and over. Okay. Now, question. I've asked this before. Why does he not go back this direction? Right, we know you can't take the square root of a negative. What happens when you take the square root of a negative?
No, you can have negative.
What is it? I. They're imaginary. Perfect. So he's only going to start there and he's going to go on forever, right? Okay, now let's talk about some ways that we can cheat by graphing. So we have this function. We know the square root of x looks like something, and we have to figure out what the plus 4 is doing. Anybody want to take a stab at what the plus 4 is doing?
No. Moving it over to the left 4.
Ooh, good. Okay, so this last period I asked that question, and they said moving it up 4, okay? So we're going to write the rules off to the side over here. Up 4 is actually going to look like this. Do you see the difference between this one and this one?
Yeah, definitely.
You see the difference between those two?
It's a big difference.
The 4 is underneath and the 4 is on the outside. This is going to be up 4, okay? Up 4. Write that rule down, okay? Down 4, y equals the square root of x minus 4. This is down 4. Down 4, okay? These are rules so that you are allowed to cheat. So we don't have to plug points in, right? Okay, if we have y equals the square root of x plus 4 like this, where the 4 is underneath of there, which is what this is, okay? That is to the, Remington said it right. This is to the left 4. That confuses people because plus should mean to the right 4. Okay? This is to the right 4. Okay? So when you're doing the ones where the numbers are underneath of the square root, you use the opposite sign. Do you remember me talking about that? The opposite sign. So plus actually means left, minus means right. Got it? Okay, so these are rules that you get to use so that we can cheat when we're graphing, right? We don't want to have to plug points in like we do up here. I don't want to have to do that, okay? We're going to cheat here in a minute, okay? Good? All right, so these are the rules. Okay, let's go over to here. What did this plus 4 do again when it was underneath like this? How does it move it? To the left 4. Okay, so I'm going to put that down. And we're going to do a little rough sketch of what this looks like, right? So if he's going to the left 4, 1, 2, 3, 4, he's going to start here, and then what's he going to look like?
Really positive.
He's going to go like this, right? That's what the square root looks like, okay? They want just the domain and the range. They want domain and range, okay? All right, so we're going to talk about domain and range, and then I'm going to show you how to cheat, okay? Ready? Domain is the x's. No.
Minus 4.
No. Domain is the x's, and the x's go left and right. So will this thing go to the left forever?
No.
No. Will he go to the right forever?
See?
Or yes.
Yes, he'll go to the right forever. So we're talking about the x's that are what?
Greater than or equal to negative.
From here he goes that way, right? Greater than or equal to -4. Do you see how that works? Greater than or equal to -4. Okay, the range, will he go up forever?
Yes.
Yes, as he goes out, he is going up, okay? Will he go down forever?
No.
No, so we're only talking about y's that are greater than or equal to 0. Now, some people, it's tricky for them to figure out what these numbers are, like where those numbers are located, okay? So here's how you cheat. Ready for this? Okay? What's the coordinates of this point right here? -4, 0, where -4 is the x coordinate and 0 is the y coordinate. So you can literally get those numbers off of the point where it starts, right? Does that make sense? Okay, that makes it a lot easier. All right, good? All right, we're going to write down some more rules really quick. Let's say I have the function y equals 4 square root of x. Let's say I have y equals 1 over 4 square root of x. Let's say I have y equals the square root of 4x underneath and y equals the square root of 1/4 x underneath. We're going to talk about those rules really quick. Okay? All right, all right. These are more rules that help us cheat, right? Because we don't want to have to plug points in. We want to just be able to cheat, okay? If you have a 4 on the outside like that, what does the 4 do? Like if I have this 4 right here, what does that 4 do? What? It's multiple. No, up 4 was this one right here.
Vertical
stretch.
Okay, it's making him taller by 4, which is a vertical stretch by 4. That makes him taller if you want to put that in parentheses. Okay, what happens if that number is 1/4 instead of like 4? It's a vertical compression. That makes him shorter, right? So vertical compression by 1/4, which makes him shorter. Okay? All right, what happens if the numbers are underneath of there? Like if 4 is underneath of the bar.
Horizontal stretch.
It's going to be a horizontal. This number is 4, and 4 usually means bigger. But these two is kind of like these two where it was the opposite, right? So here we use the reciprocal, right? What's the reciprocal of 4? Yep, so this is going to be a horizontal compression by 1/4 because the number was 4, but we use the reciprocal, so we flip it. So we make it 1/4. So what does a horizontal compression do? Horizontal compression.
Wider.
Compressing means smaller, right?
Oh.
So that's going to make it
Thicker.
taller and skinnier. It makes it skinnier. So I'm going to put skinny. The 1/4 makes it skinny. I'm watching you. I see these things. Skinny. It makes them skinny. Okay? This one is going to be a horizontal stretch by 4. What's a horizontal stretch do?
Wider.
Me, right here. He makes him fat.
Different.
Okay? Like I'm stretching horizontally every day, right? It makes him fat, okay? So it's the reciprocal when it is underneath, right? Okay, so those are some rules. 2 more things. We have negatives sometimes, and we have y equals the negative square root of x, and we have y equals the square root of a negative x. We're going to talk about both of those here in just a second, okay? Let's write down what those rules are. Let's write down what those rules are. What does the negative do when it's outside of that thing? It makes the answer to that negative. So what does that do to the graph?
Down.
Makes it go down.
Nope. Oh, yes, you're right. I'm sorry. Yes, it flips over the x. So like down, it flips him down, okay? It flips so it does like this thing. He goes down this way, okay? Now, I have a lot of people on this next one that get really confused because they're like, I thought you couldn't take the square root of a negative number, right? And I agree with you. I can't take the square root of a negative number, but that negative inside of there, if I were to plug, let's say, a -4 in for x, right? And I apply a negative to that, that would end up making the square root of a +4, okay? So I can have this negative right here as long as the numbers that I'm plugging in for x are negative also to make it positive. Does that make sense? Okay?
Yes.
So your final thing after you plug your x's in can't be negative, right? So what does this thing do?
Up. Like flip over.
Flip over the y-axis. So it flips them to like to the left. Left. Let me write. Okay, flipping over the y-axis is going to flip in this direction. Instead of going to the right, he's going to go to the left. Okay, because I am plugging negative numbers in here to make that positive now, right? Okay, kind of confusing. Flipping over the y-axis is going to move him to the left, right? Left, right, okay, whatever. Okay, good? Yeah? Okay, now let's cheat. Here we go. A, they kind of switch gears on us because we're not talking about a square root function. We're talking about an x squared function. What does he look like? A parabola. Okay, what's this 1 do? Up 1. So he looks like this, right? This is what your parabola looks like. Guess what? I know the rules, so I don't have to do this anymore. Right? I know what the +1 does, so I get to cheat. I don't have to do that anymore. Look at how much time I saved not doing that problem, right? Okay, they want one more thing. What else do they want? Graph each function, state the domain and the range, okay? The domain is x's, left and right. Will he go to the left forever, right to right forever? Yes, so what do we put?
R, the R thing.
The R, all real numbers, or you can put like infinity or whatever, okay? Domain is all reals. Range is up and down, or the y coordinates. Will he go up forever?
No. Oh, up yes.
Will he go down forever? No, he's only y's that are
1.
Greater than
y. 1.
greater than or equal to 1. Yeah. Okay, good?
Oh, 1.
Good? Got it? Okay, B, I'm going to change this problem just a little bit and make it a little bit easier. I'm going to get rid of the 2. We're going to keep the negative, and we're going to get rid of the -1. We'll just do those 2 at a time, okay? So I'm changing this function. We're just doing negative square root of x plus 3. So I'm going to change it. We're only looking at that, okay? Only looking at that thing, all right? Only looking at that. I'm going to get rid of the 2, and I'm going to get rid of the 1, but we're going to do this, okay? Now, we have to decide what is the 3 doing to it?
Moving on X.
Horizontal compression.
Left.
Nope. Horizontal compression would be like multiplying by 3, okay? This is plus 3. It's going to the left 3, right? Okay? And then what's the minus doing out in front?
Down.
It's flipping him down. So flip down, okay? So, and this is a square root function. So we're looking at the parent function for like this guy, right? Like one of those things, the parent function, okay? So we're going to move him to the left 3. So instead of starting here, we're going to go left 3, and we're going to flip him down. So instead of going this way, where he's going to go down that way, okay? So that's what he'll look like, all right? Good? Do you understand why this one was a parabola and this one was a square root function?
Yeah.
Yeah? Because they're like this was x squared and this was square root, right? Okay? All right. So we have this going on. Then we want domain and we want range, all right? Up above, we cheated. We found this point right here. Okay, what's this coordinate point where it starts?
-3, 0.
-3, 0. Okay, so I'm going to use that for my domain and range. X's and Y's, okay, for the domain. He will not go to the left, but he will go to the right. So the X's have to be what? Greater than or equal to this number right here, -3. Okay? Now the Y's, he won't go up forever, but he will go down forever, right? So Y's have to be less than or equal to. Because we flipped him down, now he's less than, right? And he's less than or equal to
0.
this number, right? Oh, my -3 got taken off of there. Anyway, less than or equal to 0. Good? So domain and range, find this point and that will help you, yeah? Okay, let's go to the backside. Just a couple more things. On the backside, they went ahead and they were graphing frequency versus tension of a, is this a guitar? Guitar, okay, guitar strings. So frequency versus tension, which one determines your pitch? Pitch is the same thing as frequency, right? Okay, pitch and frequency are the same thing. Now, I guess I should say tension will tell you what your pitch is. So the more tension you put on the string, the higher the pitch will be, I think.
Yes.
Right? Yes? Okay, so if I increase my tension, I'm going to increase my pitch. Hence it looking like this, which is a square root function, okay? This is actually the ugly square root function, right? Look at all those ugly decimals. Ugh. Now, they have already done A for you. Graph the function for the tension. I went ahead and put that on there so we don't have to graph it. It's there. We just have to answer part B. How much tension is needed for my pitch to be more than or over 200, okay? My pitch is here. Here's where 200 is. Here's where 200 is. What tension do I need to have in order for my pitch to be more than 200?
5 or more.
5 or more. Do you see how that works? Like 5 is here, and anything over 5 will have a pitch over 200. You see that? So how do I write that? Tension is capital T.
Greater than or equal to 5.
Now, is it greater than or equal to 5 or just greater than 5? And then we get to decide.
They're equal to because-
If I want my pitch to be over 200,
Oh.
I don't want it to be equal to 200. I want it just
So
over
just
200.
bigger.
So just greater than 5. If it was equal to 5, it would be exactly 200. I don't want it equal to 200. I want over 200. Little specifics. It's fine. Okay? T is greater than 5. Got it? Okay, now, this last problem is the whole reason why we're even learning what square root functions look like right now. And it's talking about inverses of the square of x squared. Okay? Let's graph what x squared looks like. Do you know what x squared looks like?
Parabola.
He looks like a parabola. Okay, they're only giving me like the first quadrant here. So like he looks like a parabola. If I do 1 squared, it's 1, 2 squared is 4, 3 squared is 9, right? Like this would be the 1/2 of the parabola and he'd go this direction as well, right? But they're only giving me the one coordinate, okay? Or one quadrant.
In a test,
That's what the square root function looks like. What?
like if I'm gonna do just one of the half of the
Yeah, that's
parabola,
fine.
it's okay.
That's fine. Yep. Okay, they want us to find the inverse, okay? So we're starting with this function, and we're wanting us to find the inverse, okay? The first step to finding the inverse was to change it to y. Y equals x squared. The second step, x equals y squared, okay? The third step is solve for y. I want to get y by itself. How do you get y by itself? Yeah, you take the square root because that will get rid of the square. So I have y equals the square root of x. Okay, and then I can rename it in step number 4. So like f inverse is the square root of x. Okay, what does the square root of x look like? Like this. That's what the square root of x looks like. Now, how do you know that those are inverses of each other?
Y equals X.
When you flip it over top of that line, does they look the same? Yeah, like it's like this part and this part looks the same, right?
Mm-hmm.
Yeah? That's the whole reason why we're talking about square roots is because we just talked about inverses, and a square root is an inverse of x squared. I said inverses undo one another, right? Does a square root undo a square? Yes. So that's why we're talking about square root functions is because we just did inverses. Okay? Good? Happy with that? Okay. Let me give you your paper, and I'm going to keep recording this for Chloe. But let me give you your homework assignment because we're going to do like a couple of these together, okay? Just so that you get like ready to go.
Hurry up.
I'm hurrying.
Yeah, we got
Um,
like
5 minutes.
Oh,
5 minutes.
7,
7 minutes.
But it's called homework.
What is off?
7
Why?
minutes. Easy peasy.
Why ever?
Okay.
All right. Here's what I want you to do for homework. For homework, do 1, 2,
Wait,
3, 4,
Wait,
5,
which
6.
side?
Which side?
It's only one-sided.
I just turned it.
Let's go.
I need 2 seconds. We were just clicking.
Okay. Do all of them 1 through 6.
Which?
Ah,
That's it?
all of, no, it's not it. Then do 7, 9, 11, and 13. So odds on the bottom and all on the top. Okay? We're going to do 2 of them together. We're going to do number 6 real quick together. And we're going to do number
13.
11 together. We'll do 13 together tomorrow. Maybe. Okay? 13, read the dang question on 13.
Now we don't.
Nah, well, if we have time, we'll do 13, okay? But number 6, let's do this one. Number 6 is just asking, identify the transformation, okay? Here we go. Identify the transformation. That means up, down, left, right, stretch, compress. What is it doing, right? So number 6, the reason why I picked number 6 is because it has a lot of things going on there. How many things are happening?
Can I delete it?
3.
3 things are happening. Number 1, number 2, number 3. Okay? 3 things are happening. Now, when you get into trig class and we start doing this in trig 2 years from now, listen, when we start doing this 2 years from now, you will need to make sure you put them in order, okay? Because order does matter. If I move something up and then flip it down, it's different than flipping it down and moving it up, right? It's going to end up in a different spot. So we have to put them in order. If we put them in order, which one of those comes first? The 5, the 2, or the -1?
5. 2. Negative or the 2.
Do you want to know how you know?
Is it like
If you were to plug a number in for x, would you multiply by 5? Would you add the 2, or would you subtract the 1 first? Add the 2 first. You would add the 2 first, okay? What does the 2 do?
Parabola. Oh.
Left 2. Okay, then is the 5 or the 1 coming first or coming next? You would multiply by 5 next, okay? What's that doing to it?
vertical stretch by 5.
Vertical stretch by 5. Okay, then the -1 happens last, and that moves it
Down 1.
down 1. Okay, do you see how this works? Okay, For algebra, if you were to put them out of order, I am gonna like not take off points for that, but when we get to trig, like we'll start having to make sure that they're in order, okay? Because it will matter. All right, let's go to number 11. Is this
Wait,
11?
It's done? The 6 is done?
That's it. That's all you have to do.
Oh.
Identify the transformations. All right, how many things are happening on 11?
2.
2. Okay, which one's happening first?
7.
The 7, the plus 7. What's that? How does that move?
Left.
Okay, it moves into the left 7. All right, what's the minus 4 do?
Down 4.
Down 4. Okay, so I'm going to go left 7. 1, 2, 3, 4, 5, 6, 7, and down 4. 1, 2, 3, 4. That's where my new dot is going to be. And then what does he look like?
Like the shoe.
Ding! Just like that. Just like
What did you
normal,
say?
right? He just moved over and down. Okay, we need one more thing.
Domain and range.
Domain and range. Let's cheat.
Again, tomorrow we will run the MAPS testing schedule. Seniors, you do not need to be here until 9:30. Everyone else, you need to be here by 8 o'clock and go to your first hour class.
Does Chloe know that? Chloe, we're running
We'll
MAPS testing
have
schedule
FBLA
tomorrow.
meeting tomorrow. The
So
last
if you're done
meeting
MAPS
is at
testing, then
one
you'll have a
meeting
study
in
hall
the high
from 8 to
school
9:30.
library. The Valentine's Day Eileen's Cookies, the Breakfast Book
it
Club will be
minus
taking cookie orders until noon
four
on
minus
January
7?
20th.
Other way around.
Any
much is it?
unpaid
Minus
orders
7.
after
Oh,
noon
wow.
will not
Oh,
be
yeah.
charged.
I forgot.
Orders are on the table outside of the office.
Bro, I just
The
started like
FFA
15.
holiday party will
Bro,
be
I know
on
I'm just
Sunday,
stuck and I
January
can't change my weight,
21st
so I'm
at
just like
7
standing
o'clock
there and
in
like.
the Commons.
Yep.
See Mrs. Boniface if
I'm
you
doing
have
it
any
on computer.
questions.
I'm doing on the computer.
Okay, last thing, domain and
My
range.
bench, bro, I'm spending-
Toby gave us the
No.
coordinates for this dot where he starts. He said it was negative
You're
7,
welcome.
negative 4.
Pause, Mr. Move is like 50 seconds,
Negative
bro.
7, negative
Pause,
4.
Mr.
Okay,
Move, change
X's.
the way.
Shh, here we go.
Nice.
X's. He will not go to the left forever, but he will go to the right forever, so the X's have to be
Greater or equals minus 7.
greater than or equal to minus 7. Okay?
So
The
small.
Y's. He will go up forever, but he won't go down forever, so Y's have to be
Bigger than minus 4.
greater than or equal to minus 4.
Oh,
Got it?
Uh-huh.
Perfect. There you go.
13.
Okay?
Wait, so this thing is
We'll wait
same
for
like
13
the
for tomorrow.
first? So this is same like this, but there is the graph.
Yes.
too? Okay.
Yep. Okay? All right, goodbye, Chloe.